Hi YouTubers, this is Sine-wave here. Haven't posted for a while, so I thought I'd let you know what I've been up to. This is my portable power supply. It's battery driven into an inverter, which is 3000 watts pure sine wave continuous, 6000 watts peak. It can be charged via solar or by a motor and alternators, which are in here. Try and get a look for you. And then the battery power goes to the inverter, which is down there. And it comes out here through the power points. There's two of them, one there, oops, and one there. Now when the inverter is switched on, you can read the volts and the amps draw on each one. It goes through what they call an RCD, which is an earth leakage detection, and an overload for each circuit. On the top we have gauges that will read the battery voltage when it's charging or running. We also have a gauge that reads the input amperage into the battery from the alternators. And this switch here, which I've happened to broken the switch off, this gauge I should say, reads the battery draw when the inverter's running. But also up here we have a 12 volt outlet with 3 cigarette lighter plugs and 2 USBs if you want to use 12 volts, which is very handy. So if we turn those off, put the camera down for a sec, I'll show you how this thing unfolds. Excuse me. We open up one and we open up the other. It stays. And we have our solar panels open. Grab the camera again, take you around here. It's our power supply, which is a 4 horsepower 2-stroke engine, fuel tank, an isolator switch that when switched to 1 engages the batteries to the inverter. You can isolate them when off. We have a charge controller here, which is 10 amp charge controller working off the solar panels. If we turn the panels on, you'll see the open circuit voltage goes up to about 20. Then we engage it to the battery and it'll drop down. At the moment we're putting out nearly 2 amps and it's not even facing the sun. On full power it charges the batteries at about 5 amps. Another look from the other side. Alternators. We have a shunt here to measure output if we need to. Fuses here in line. That's the other end of the inverter. It's belt driven. This shunt here is a 350 amp. It's from the battery to the inverter, from the alternators to the, from the battery to the inverter, that one is for, which reads on the middle gauge. Anyway, I'm going to put a third battery in it, just to give it a bit more life, which is this battery here. And we're also working on the twin cylinder. We're going to update this a bit. We're going to make it crank rate inducted, give it a bit more power, a bit more easy to start, and put the electric starter on it. Anyway, that's all for now. Just thought I'd give you an update on what I've been up to. Thanks for watching.